Welcome to this month's webinar, Smart Cities IT Infrastructure Overview. We have today with us Jeffrey Duku from Autonomy Institute. Jeffrey, would you like to introduce yourself?
Sure. So Jeff Duku, chairman of the Autonomy Institute. The Autonomy Institute is a 501c3 focused on accelerating the path to commerce for intelligent and autonomous things. So everything from rovers to drones to think about shuttles being able to in effect increase mobility within cities.
Great. So Jeffrey, we're talking before we started the webinar here, and let's start with some basic principles here, and kind of like start defining what are smart cities. What is the vision behind smart cities?
Directly to us, how we view smart cities.
Yeah.
I think the aspirations of smart cities is to make cities more resilient and more responsive to the communities. So how can they make the individual residents of a city more productive and really meet the needs of what the citizens want, but also make the city itself more resilient, realizing that I think we're obviously the majority of people are moving to cities now. I can't remember the statistic for how many people are going to be in the cities, but the urban development is going to be a thing that we have to plan for, and cities have many challenges that have to be addressed. If you think about the number of services they have to provide for to make a resilient community, it's immense. And the more intelligence that can be put into the environment, the more resilient they can be to meet those services to the community.
Cool. So really what we're trying to do here is kind of like I wouldn't say automate in a city, because that's not that's smart, but not really smart. I would say like the idea of smart cities is probably like taking cities to the autonomy point where cities are autonomous, right?
Yeah, that's definitely our perspective. There's a lot of stats about how automation has impacted agricultural fields in rural communities, how we're able to dramatically increase the amount we can produce in the fields. There's incredible statistics about what automation has done inside factories to able to produce goods and services far faster and far more resiliently. But many of those same principles are now being brought to the city on how can the city be more responsive, far more productive, but really make it an environment in a community that people want to be part of. Because as the population growth continues, we have to be far smarter on how we respond to this growth, and far smarter and really kind of meet the needs that we as citizens really want to see within cities. So it's automation. If you talk to us, we believe automation can do a lot of things within city, not just have a better awareness of what's actually happening in the city, but if you can truly automate things like small shuttles, think about thousands of small shuttles within the city, personally picking up grandma and taking her to the local store and back home, has a lot of value within communities. Or having drones or rovers on the ground delivering groceries to people's homes. It in effect meets a lot of the frustrating experiences that cities experience with the density occurring that we're seeing within cities.
Yeah. So really, at the end of the day, with smart cities, I would say that from one side will be having more insight over what's going on because we're gathering a lot of data, and I think on the other side that could be seen as automation, or I would think of it more like as autonomy, especially when like you mentioned the shuttle. That shuttle is going to be a self-driving shuttle probably. So it's more in the side of autonomy than automation is way more advanced than simple automation that we have in oil fields or industries like with PLCs and ladder logics. Like we're way more advanced than that. And so with all of that, like we're going to define instead of operating all of that ourselves, like humans or cities themselves, they're going to have technology operates those millions or billions of tasks that need to happen every day throughout the city, right?
100%. I mean, I think I think all of us have experienced, different automation in different degrees in our lives. And I think the goal with intelligent cities, smart cities, is making those experiences more, kind of invisible to us as individuals on how they actually happen. It's just like it's magically you get into a car that takes you directly to your location. You don't have to give it all the data that you need. Like I need to go to this location and communicate all those different aspects because the environment will already know that you're looking to go from the location you're at right now to either to another meeting or to a nearby restaurant that you're already scheduled to go to or such. But without more intelligence within cities and more sensors within cities, it's going to be very difficult for a city to maintain a resilient environment. And I think that's where there's a lot of development, a lot of dollars being spent on and making sure that we have proper connectivity, plenty of water, plenty of electrical distribution. And I think a lot of cities are starting to be surprised by just the electrification of mobility, which is all really positive to the environment. But what cities are realizing is their electrical grid was never engineered to have so much amp draw across the city to support just charging of mobility, electric mobility.
Yeah. So before we switch gears a little bit to the IT infrastructure that is required to implement all of that, we were talking earlier before we started the webinar about digital twins and how they're picking up momentum and finding a very important place in the implementation of smart cities. Would you want to kind of like cover that again here?
Absolutely. In fact, digital twin is one of three pillars we kind of see attributed to building an intelligent city. One that you'll hear Autonomy Institute talk a tremendous amount about is the intelligent infrastructure and things like PINs, public infrastructure network nodes. The other you'll hear us talk about is the basically data exchange at the city level, where data is actually staying sovereign to a city. But the third, and it actually happens to be the first that's implemented, is the digital twin. It's not just the digital twin that a lot of people think about, which is the GIS or building information management representation of the city, like what the buildings look like and where the utilities are. But it also includes an environment that you can actually do full simulation and modeling and testing of various scenarios of different devices that can be implemented, different services that can be provided to the community. And the third part of that digital twin is really the operational, or we say the active digital twin, is how can you operationalize a city leveraging the digital twin as the main vehicle to monitor and manage and facilitate the services across the community.
Cool. So basically, you mentioned digital twin, but you also mentioned two other pillars, and one of them is the network infrastructure, and the Astronomy Institute is contributing to that through the PIN. Do you want to kind of like tell us more about that? You can explain what a PIN is and why it's important to have that infrastructure around a city.
Yeah, maybe I can pull up a slide or two, but I'd say the PIN, the what's called the Public Infrastructure Network node, became something that the Autonomy Institute championed primarily because we spent a lot of time working with cities in 2018 and 19, looking at how new technology could be implemented. Like, how can we get shuttles and rovers and more intelligence in the city? But what we did not realize was the challenge is the cities were already inundated with a lot of different requests and permits for deploying various technology. If you think about it, some cities had thousands of permits for supporting 5G. And the other issue that they had was there was all kinds of different type of traffic management technology they were trying to field. And what became clear to us is, I'm going to pull up a slide here, see if it comes in. That show?
Yep, it's online.
Okay. Yeah, so these are the three pillars that we're talking about. But I'm going to jump to this where there wasn't, is this showing public infrastructure network nodes? On
yes.
Your slide? Okay, great. So when we first started talking to cities, the PIN wasn't even developed because we thought it was a concern that was already being addressed. But when we started talking to cities in late 2018, early 2019, saying we want to work with some very big partners and bring in different sensors and different devices that can support these robust applications for their citizens. As we explained to them that various devices had to be deployed for supporting transportation services or advanced mobility, there had to be computing put closer to the actual transactions themselves, and we actually had to support specific type of smart city IoT devices, as you'd say. What we were met with is cities basically very concerned. In fact, what they saw in our conversations with them is that additional blight was coming to their city. So these are a lot of the pictures that were shared to us by various cities that we talked to, because in effort for the United States to more rapidly adopt 5G and make sure that we have a resilient backbone of wireless infrastructure, the FCC mandated the ability for carriers to deploy by strapping, bolting, or attaching different wireless devices and antennas and stuff to current infrastructure. So what the cities heard us saying is we want to put more individual devices within your city. And that created tremendous amount of concern that they had. And in fact, a lot of cities sent pictures like this to us. So these we thought were not real, but if you look up the history, these are actually real pictures of the 1930s and 40s during the explosion of the electrification and the telecommunications within our cities. And what the city quickly realized is the same thing was occurring again. And if we did not find a solution to this, we were going to be inundated with, number one, services that really did not meet the community needs, but also security and operational management that was impossible to actually manage over time. And we ended up spending a lot of time with Crown Castle and American Tower and a lot of the providers that have really led the industry forward with macro towers and other enabling technologies. But what became clear is there was a concept called a smart pole, developed by many manufacturers, but it was born out of a LED industry. So it was all the lighting companies trying to sell what at the time was a very expensive LED light, and they were trying to add additional services to it to make it more attractive. What really needed to take place, and is what developed into the PIN, is how can you create a new real estate asset, which the PIN is now being classified as a new asset class within cities, just like we have roadways, we have apartment complexes, we have buildings, we have condos. As we progress forward, the PIN will be a new asset class deployed on private property, deployed along highways, deployed within cities. And it's basically a condo, but a condo for electronics, and a condo for sensors, small cell, intelligent transportation devices, edge computing, even VRAD, technologies to support the massive adoption of new infrastructure. So that's where you'll hear the Autonomy Institute talk a lot about, because the Autonomy Institute is looking at how can we solve for enabling applications of autonomy within a city, but without the quote highway of those services, which is what is becoming the digital twin. We're not going to be able to push out the right sensors, the right edge compute, the right software platforms to enable these.
So I have some questions here around like how the pins are deployed. Are they like meshed together? What backbone they're going to use, to connect to the rest of the world or the internet? And what kind of just on the kind of like addressing the technical side, what kind of connectivity is going to be there? I've seen on the slide like a 3G. I think I've seen LoRaWAN, other technologies, and what kind of compute will be in there as well.
Well, so let me make sure we set context properly. So all of us on the phone are pretty much software people. I mean, we my entire career has been enterprise software. The PIN needs to be thought of as something independent of technology. It's so you do see us talking about the PIN in context of 4G and 5G and LiDAR and radar and edge compute. But the first concept that people have to understand is it's a real estate play. I mean, it's cities have valuable real estate that right now, industries like carriers, like the communication industry, want to deploy technology. It's also places that smart city companies like the NTT and the Siemens and the Hitachis of the world want to deploy technology. It's also the same real estate that intelligent transportation systems are currently deployed. So if you pull up to a four-way intersection that's controlled, if you look across, there's going to be one intersection, one corner that has a silver cabinet installed that basically has the control logic for that intersection. So the Autonomy Institute is want to make sure everybody understands it's a 501c3. It's not a commercial entity. It's an entity that's trying to be the catalyst to allow the United States to catch up to what China has already implemented. China has already implemented over 800,000 5G nodes. Let me ask you a question. How many of you think 5G nodes have been deployed in the United States?
That was actually going to be my next question for you.
Yeah. So based on all the data, it's still, we have yet to cross over 19,000 5G nodes. And the reason is not because we don't aspire to have the best 5G networks. It's not because AT&T doesn't want to service us with 5G. or Verizon or T-Mobile or any of the other players. It's because it's extremely costly as an individual provider to go and set up a smart cell, or what's a small cell device on a street corner, supplying service for a single use case. I mean, right now the estimates and actually the real numbers that we've seen is between $60,000 and $130,000 is being spent for a single carrier to install 5G at one intersection. So the economics, the reason we don't have what a lot of people may know, but 5.9 gigahertz was dedicated to the transportation industry, US DOT, over 20 years ago. The reason that technology is not everywhere like it should be is because the cost to implement the 5.9 gigahertz at the density it needed to be deployed was too costly for any one industry to do it. And what the PIN and what our collaboration with very big players, like the Raytheons and the HPEs and the Ciscos of the world is done is solve for how can we have a physical infrastructure. I don't like to use the word dumb, but it's not prescriptive of any specific wireless technology. It's not prescriptive of any application. It's not prescriptive of any LiDAR technology, but it's instantiating a physical infrastructure, a condo that allows cities to embrace intelligence without having to make a technology, decision.
Cool. Thank you, Jeff, for explaining like what the PIN really is, and I think it makes sense. I mean, from the point of view where it is a real estate, and that's really the big problem for us to have like that connectivity everywhere. If there are no questions, do we have questions, Sash?
Yeah, I'm not seeing anything in the chat channel, but we got looks like somebody just put something in. What do you think about 6LoWPAN as communication standard for smart cities?
Yeah, I saw that from Carlos. I think there's a lot of standards. I mean, right now we have weekly meetings with US DOT, Federal Highways, the FCC, DOE that has a lot of interest in communication devices, but also a lot of industry players. Like you have Amazon very aggressively, very successfully implementing things like 900, megahertz, a mesh network across cities and across communities to have more resilient backbone for IoT devices. I think all those standards are great, and we're from an Autonomy Institute standpoint, we just want the best to win, and we're trying to provide the platform and the real estates and the facilities to allow that to happen much faster than it has, because we're currently well behind other nation states on what we can do with intelligent infrastructure. But we do have incredible industry solutions that can be implemented. But if everybody has to go try to attach to camera or a LiDAR or some edge compute or some 5G device independent of some integrated fashion, we'll never get there. And that's the challenge that we have to solve. It's an ecosystem play, but it's a play that now we have over 130 industry partners involved, and it's one that's going to start netting incredible impact to our citizens as we get this infrastructure deployed.
Cool. Thank you, Jeff. I would ask you like a last question here. So, in the context where the PIN and similar like alternatives are real estate, where telcos would deploy connectivity and other players would deploy compute or whatever is needed there. Do you think that at the scale where this is going to go, it would make a lot of sense to automate all those transactions through a DLT, or commonly known as a blockchain?
Yeah, and so I want to be careful. So a resilient ledger, whether it be blockchain or another enabling technology, because everybody has their own perspective. But we mentioned three core pillars. The actual physical pins, the digital twin, and the data exchange. So the data exchange is going to be vital for a mechanism like a blockchain to be successful, because you have to guarantee that data is going to be controlled and is going to be utilized to the benefits that the community wants to support. And I think we've seen a lot of smart city initiatives get shut down because they really didn't address how the data was going to be managed and controlled from the community aspect. Nobody wants to see their data sucked into a cloud and not really know how it's going to be utilized, to their benefit or also to their non-benefit. And so I do agree that there's going to have to be some strong mechanism for ledger, and I do believe blockchain provides an unbelievable mechanism for doing that. And we just need to start seeing some of these deployed, start seeing data captured, because I think a lot of other things that people don't realize and why it's important to have something like a blockchain is not knowing how much data is going to be captured. So I'm gonna share this screen. Tell me if you see it. Do you
Yeah,
see
I can see it.
Yeah. So the first thing people, I think there's going to be densification of compute closer and closer to a city. There's going to be compute at the bottom of cell towers. There's going to be compute in buildings. But the amount of data from the sensors of a single pin will produce in excess, tremendous excess of over a petabyte of data being processed per month. That data doesn't need to be saved. It doesn't need to be stored or transmitted back to a big cloud, but it does have to be processed. And in order to do that, you have to have compute all the way at the edge, and you have to have a mechanism of securing and assuring the citizens that data was going to be used to their benefit, their economic benefit, their personal experience benefit, because this is this graph we used kind of showing the supply chain of data just specific to machine to machine. So you think about the number of sensors that would and will most likely be deployed at a pin to support a shuttle being deployed resiliently within a city to meet those needs. It's a lot of data. Nobody wants to see all this data, especially personal identifiable data, ever transmitted beyond this point, because the reason that the pin will exist is to support the use cases, not support data going back for other use cases, unless the citizens accept for that. And that same data not only affects the autonomous world, but it affects public safety. It affects many other city services, city planning, more advanced response to disaster activities. And all that comes down to how can we instantiate this new architecture. And we equate it very much to, if you think, back in the, let me just stop this for a second. If you think about back in the 90s, a lot of people didn't think that data centers was going to be a thing. When we started one of my first early companies, we actually had to buy a tremendous amount of infrastructure from Cisco and pay $50,000 a month through 3 different carriers to basically properly service our customers. And back at that time, they just thought it was a network issue. What that evolved very quickly to is all the servers and all the compute were also put in these exchange points because it made more sense to process the data where the data was being captured. And that's the same thing that's going to occur at the pin. Is if you can process more data at the pin versus backhauling it to even a regional data center, you're going to save money, but also you're going to be able to provide far more robust services.
For sure. Totally agree with all of that, and especially the like the enhanced user experience through like edge computing. Like, response time will be way faster. Your data are going to be is going to be protected, not sent to the cloud or whatever. So yeah, that's
So Sammy, I've done a lot of talk. Tell me, how do you see the world? How do you and Ashwin see the future and what's going to happen?
Yeah, so I mean, personally, I think a concept like the pin that extends the compute and make that almost like ubiquitous throughout the city. Add to that like devices that are connected to it that are also capable of computing, regional data centers and data centers across the world. I personally see it as a mesh network of computing capabilities, like more like a brain where every neuron can run compute, and software will need to run across that neural network that's global, and why not interplanetary as we are going to space, right?
Yeah.
So in my mind, we'll need to change to some extent how we see software, how we architect software, and move away heavily from the hub and spoke and centralized approach to more distributed approaches where data, like you said, is processed at the edge, where machine-to-machine communication can happen without that communication going through a central server, like what's happening right now with this meeting, right? So for us to get there, to be able to handle all that amount of data, to implement all that autonomy around us and intelligence, we will need also, in addition to infrastructure, we'll need to change how software is built. Need to change software architecture, how software is thought of, quite radically, I would say.
I would definitely agree. I mean, simply pushing Kubernetes out to the edge is not going to solve the problem, the fundamental problem that is going to be experienced.
Correct. It's really how software is being built. There is the centralized model is so mainstream, so easy to grasp. Like you have clients and they're communicating with a server, and it's easy. Like developers and like architects say, oh, that's simple. We have clients that communicate with a server, very, very easy. What they don't realize is that end-to-one is going to transform to end-to-end, because on the server side, you're going to implement a load balancer, and now you have multiple servers. And now you end up with an end-to-end architecture that is very, very hard to scale and way more complex, right? And then we start like kind of like at some point we'll say like, hey, all of that data is convergent to one point. Now we need to have multiple or shard that or distribute that, and and on the software side today, it's being done kind of like in a declarative way. I have like 16 shards, and then those shards are in 16 regions, and I distribute that. But the edge is dynamic. You never know when data is going to show up, and this is why I think we need really to implement autonomy, where software can operate itself, can dynamically determine with whom to communicate. Machines should be able to dynamically figure out peers around them and communicate with those peers, provide services between them, instead of always going to a predetermined path that has been coded somewhere. You have to go there to get your data. You have to go through that service to authenticate and so on, and so on. So we will need to heavily move away from that and move to a more distributed architecture. And I believe that DLTs are one part of the big solution, one important part.
No, I would agree, and also it's addresses sovereignty of data. It's really addresses data that's being captured within the city of Austin to basically support intelligent autonomous things. Doesn't really get access anywhere else in the globe unless some type of research project or some other type of analysis is being done. So it really allows far faster response. The latency becomes to the point where the resilience of an autonomous shuttle being deployed and staying safe in all aspects, it doesn't matter what speed, becomes something that is actually very easily designed in a system. But going to the cloud, it becomes an impossible challenge that continually breaks.
Yes. Yeah, correct. And I mean, people are experiencing that in very simple use cases, just some of those home automation devices and products that people have at home. They're not very responsive because they rely heavily on the cloud.
Yeah.
And we may think that the cloud is limitless and infinite, but it's not. Your Alexa, turn on the TV or turn on the light, is going to a queue. And this is why it takes few seconds to come back to you, in addition to the latency. So yeah, that's, I mean, not everybody has like a smart product in their houses, but once we have trillions of those, getting that response or that processing from a centralized wherever, cloud or data center, wouldn't be a viable approach. And that kind of comes back to what I was saying, like software needs to be decentralized. We need to break away and walk away from that centralized approach that software engineers and architects like to use, because it seems simple at the beginning, or to implement initially, but it's very, very hard to scale, especially when we're talking about horizontal scale.
Yeah, I mean, considering some of the implementations that we're talking about for pins, like City of Austin would easily be 1,500 to 5,000 pins. So in each of these pins, fully scaled out, could be between 10 to 20 kilowatts of compute. You're basically talking about a 60 to 100 megawatt data center sprawled across the city. And with that, how each one of those pins operates, it does not represent a rack within a data center. You can't think of it in the same way. It becomes far more aware of its environments. It actually intelligently knows that is at a GPS coordinate, and it intelligently knows what services and what sensors it is aware of. And it knows what services it needs to service out to connected cars or shuttles or rovers or just pedestrians about to make a a mistake walking across the street at the wrong time. Yeah, so it's very much you don't have to convince us that a new software architecture is needed. I would kind of go back to talking about the IoT devices. It's impressive how clouds have been so resilient on keeping IoT devices quick. But what people are failing to understand is the massive spike of devices that we're going to see are devices maintaining the world around us in an automated fashion. Very few people are comprehending the number of drones, autonomous vehicles, autonomous transport trucks, the drones, maintaining our infrastructure. And that's where those devices, they don't blink. So the fact that we hit the button and our TV is immediately on makes us feel really good, but would make a machine to machine extremely frustrated and unable to do its job.
Yeah, that's totally correct. Yeah, so we are going to the world of machine to machine communication, and when a second is okay for us, it's a long time.
A long time.
Exactly. And I don't remember the scene exactly, but there is a scene in Star Trek New Generation where Data.
Oh, wait, do we actually? Wait, you got to start over. So what happened with Data?
Oh, Data, the android.
Oh, yeah.
Star Trek New Generation. Like, I don't remember the exact scene, but I think it was about a few seconds, and for Picard it was only a few seconds, but for Data, he told him, like, for me it was forever. Because my brain can think faster, right? So it's a long time, right? So same thing for machines. Like a second is a long time. Like, kind of going back to your point. Cool. I think Jeffrey, we covered a lot of concepts here about smart cities and edge computing and why it's important. And I really like, there is no escape from it. If we want to get to a smarter world where everything around us is autonomous, we have to walk away from that centralized cloud approach and embrace the edge and embrace a distributed infrastructure. And we'll get there I'm pretty sure we'll get there, and 10 years from now, people will think like, oh, I can't believe people were using that thing called the cloud, like us, like thinking about mainframes today, like, oh, people were using mainframes.
Yeah.
So
it's
quick question here for you, Jeff. We talked about the digital twins aspects of things, but I didn't hear too much about anonymizing the data. If you can kind of, critique or comment on that. I know that's not one of the big things, especially as you're like pedestrians are walking. Maybe you can give a comment on that.
Yeah, so we're heavily focused on that issue, and what we're doing with cities and state agencies is establishing a public-private partnership. And that allows kind of like the rules of the road to be determined by the community and by the city and by the state. So obviously in some cities, you might go to Chicago and they want to capture license plates and faces and everything. And then of course in cities like Austin, we're going to be hypersensitive about anything that's personally identifiable. So once again, that goes back to when the camera is deployed on a pin and the NVIDIA high performance, GPU is sitting there on record, it's actually already siphoned out anything that's personally identifiable. So it can never be reversed. But once again, we're pretty much, focused on protecting privacy, but we also understand it's going to be a community or a city or a state issue.
This is very interesting because, like, if you say like Chicago, for example, it's going to be a little bit more liberal it will be interesting to see in the future, like what sort of crime and statistics, and differentiate those among the cities that are a little bit more liberal about the privacy aspects versus those that are not. So
it will be, we talked a lot about the things that we're excited about, autonomy and edge compute and stuff like that. Probably the thing that excites the Autonomy Institute leadership, as well as the cities and states we work with, is if digital, eliminating the digital divide has become a major challenge that cities and states are going after. And what's come out is, as we implement 5G and edge computing and all these advanced sensors, it's an opportunity for us to address the scars that were really damaging across our cities with interstate highways. If you think about the last major build out we've had in the United States was the interstate highways. And a lot of people say, well, what about the internet? Well, the internet, that all happened in our own personal houses and closets and, behind closed doors. We're talking about a physical infrastructure that is going to heal those scars, eliminate the digital divide by creating robust communities. Because everywhere this infrastructure goes, which is going to be everywhere, it allows the enabling data services and enabling, intelligence services to be delivered.
Very interesting. Yeah. Regarding some of the data that you're talking about with the smart cities, lots of sensors, many different companies involved here. And so I can only imagine when you take data that comes from, let's say, buildings versus the data that comes from streets versus cars, and then new companies coming up with innovative applications when you combine those data and coming up with efficiencies for all those different applications, but also completely new applications that we haven't even thought of. And I think these are the things that are going to be possible with smart cities and especially edge computing, along with 5G, which is going to be a catalyst for all of this. So
I'm excited to see all the new applications developed. I mean, even just AR, VR alone is going to be so robust in applications running on this new architecture that, people are going to look back 10 years from now and just, it's going to be like, once again, it's like a sine wave. We've gone from mainframes to PCs to cloud to now back to edge.
Yeah. Well, cool. I don't see any more questions here, Sammy, if you want to.
So we can wrap it up here, and I have the best thing here to wrap it up. So I don't know if you can see this. This is the the scene I was talking about. So
that's good.
Yeah, I was saying 0.68 seconds, sir, for an Android. That is nearly an eternity. So this is exactly what's happening at the edge with IoT.
Well, tell me, Sammy, are you guys announcing something? Because I went to your website the other day. Do you have some new announcement coming out?
Yeah, we'll do some announcement.
Nice.
Yeah.
So it's all secret stealth still, huh?
A little bit, yeah. Cool. Yeah, thank you, Jeffrey, and thank you all for attending the webinar. The webinar was recorded, and then we'll do some video editing on it, and probably send that to everybody in a week or two.
Well, wonderful.
Thank you all. Have a good one.
Thanks a lot, Sammy. Have a good night.
Bye.